It's like the fun uncle of transformations. By the way, I forgot to put an animal on this one. I apologize. I just forgot.
No, I refuse to do work.
Where's my Japanese flying squirrel?
I have a picture on my desktop actually waiting of a Japanese flying squirrel.
You put a chameleon on the thing the last time.
Well, I googled a gecko. I did my best. I will try harder next time.
Geckos are.
That's what they
I don't know.
You know, you're
Geckos
I think geckos are
Ew.
I want a warthog on my next one.
You know what? This isn't like a buffet. We're not ordering off the menu. This is a benevolent dictatorship. I am your benevolent dictator. I'll be quiet.
So you're the prime minister?
Of course it's benevolent. Okay. So today we're going to look at one other kind of reflection that we can do that has relatively easy math to it. In fact, I would argue that in some ways this is the easiest of the ones we've done. So we are going to reflect now, not in the x-axis. And when we reflect in the x-axis, of course, it flips like this. Not in the y-axis, which of course flips like this. But I don't think I'm going to try to physically demonstrate this one. Well, maybe I am, like this. But we're going to reflect it in the line y equals x. So of course it will then flip like this. No, not doing it. So like this. I'm assuming it's all the drinking. I don't. So this is the line y equals x. Hopefully everyone can recognize that. The line y equals x just means that it starts at 0, 0. If x equals 1, y equals 1. If x equals 2, y equals 2. So it gives us a nice diagonal line with a slope of 1. And y is set to 2. That's comfortable for everyone? Sending us way back to grade 9 math. Simpler times. Right? Did you? Oh, wow.
I hated grade 9 math.
So, if we were going to reflect in this line, the first way we can do that is just visually. We can just look at this. So if you have like a reflective surface, such as a phone, you could actually put that reflective surface along that dotted line, and you could see what the reflection would look like. In fact, I encourage you to do exactly that right now. Like the red mirror ones? I looked, I couldn't find them.
Where the world looks red to you.
Right.
So why is it not doing this?
And so I am incredibly bad at this, but I will do my best. We have a point here. Oh, go away. We have like that point there would become that point there. I'm just trying to like map out where this thing's going to go because I'm bad at this. I'm not a good freehand sketcher. You know what? I'm doing my best. It's going to look, well, obviously. There we go.
Like this? Is this right?
Yeah, that's very good.
Wait, you gotta make it into a face. You gotta make it into a
Okay, so there we go. We're going to sketch out something like that. There it is. Okay. I did my best.
What?
So, here we go. Who made it into a face? Alondra, did you make it into a face? Very nice. Alondra has made it into a face, and I think that is wonderful. There we go. That's pretty straightforward, yeah? Can you guys all try? Surely you can do better than I. Try the parabola. See what you get.
I'm fine.
Try the parabola. See what you
I
get.
feel like.
I put a parabola there. It looks like y equals x squared minus 1, maybe.
Wait, this is so.
What did you even do?
Did you put circling on the next page? Where is it?
Let me show you.
Again, I encourage you to take a mirrored surface and like visually look at it, see what you get.
That's exactly what it was there. I don't like it. I don't like it. I want this one.
I want a different color.
Purple.
Oh, okay. I like purple.
I want.
Is that good?
Should we?
I don't need a new
Oh,
color.
don't tell me. I need to go to sleep.
Amen. That sounds lovely. You don't need to leave. All right, surely yours will look better than mine. Something like that, more or less.
Wait, what?
Can I see what you got?
Yeah, I went on.
Ah, you reflected just this line, right? But you need to reflect in this line. Does that make sense? I'm sorry. Does that make sense?
I'm trying to work on this circle. I'll make it clean it up. I got like
You would think, right?
be honest,
I like that. That was very good. I like this.
I heard that.
Yeah,
All right.
The circle's like,
Going forward.
wow. It's hard. I think it's worse. It is, yeah, it's surprisingly difficult. Dad, that wasn't on the original one. I'm not sure that's gonna help you like look back and see how it works, but it is lovely. I'll give you full points for lovely.
That's good. Yeah.
I don't think so.
I did. That was the first.
Have I? I must just be in a really, I'd say I'm in a really good mood, but actually I'm like shockingly exhausted and I feel vaguely miserable today. No, I don't feel like I'm in a lovely mood. I feel kind of grumpy today. No.
Oh, that's
False. Oh, you'll get the exam on the red paper now. 3 extra pages, all the hard questions. Okay, now visually, it can be a little weird to try to do that, but it's not confusing, is it? I mean, you put a mirror there, you look at what it looks like, and then you do your best to sketch it. That makes sense, right? Can I see? That looks very nice. I think you did a very good job. No. So we can also ask, why does this happen? What are we actually doing when we reflect in that line? Artists amongst us, / geometers extraordinaire, what have we done here? When we put that mirror there, what are we actually doing? When we put a mirror right on the x-axis, we said that everything below the x-axis ends up above it, and everything above it ends below, right? When we did that kind of reflection, all the y values that were negative became positive y values, and vice versa. Does that make sense? When we did the mirror this way, so that flipped like this, like queen, possibly queen b, all the negative x values became positive x values, and all the positive x values became negative x values, right? Does that make sense? So, what is happening here? When we reflect in the line y equals x, what do you think happens? Y equals x.
Oh, looks like the value switched.
The values switch. What used to be the y value is now the x value. What used to be the x value is now the y value. Good. The values just switch. All the x values become y values and vice versa. So if the original point was at -2, 3, this point right here, where will its translated point live? At 3, -2. If the original point was at -1, 0, where will the translated point? At 0, -1. Yeah. If the original point was at 0, -1, now we will have a point at -1 and 0, which we already have one there because it overlaps another point. If the original point was at 1 and 0, the new translated point will be at 0 and 1. And it occurs to me I should have used different colors for the original point, so I'm going to do that. And if the original point was at 2, 3, where will the new point be? At 3, 2. And then we can draw it pretty easily. Now, I'd like to point something out. Well, nothing's perfect. I think I did pretty well. But the original function, the parabola, is it a function?
Yes.
The original one is. It passes the vertical line test.
It's not.
What about the reflection?
No.
Not a function. Not a function.
Oh,
So
we just
it is
brought that
possible. It is possible that when we reflect something in the line y equals x, it goes from being a function to being not a function. That can happen. But does this process make sense? To map it on a table of values, I think it's the easiest transformation we do. The mapping in this case couldn't be simpler. If you take your x, that becomes the y. You take the y, that becomes the x. You just switch the numbers and you've mapped it out. So we've done this visually. We've done this by mapping, looking at a table of values. What is the third way we could do this? Visually, table of values, and then of course we could do it. Yeah, algebraically, we can work with the equations. Yeah, it's not hard, but it's harder. It's trickier. So, if I had this function y equals 3x plus 2, and I guess I should put 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2. That's the least even lines I've ever seen. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. How would I graph this line? F at x equals 3x plus 2. How do we graph a line from an equation? Anyone remember? Maybe you haven't done this in a while.
You have to find what 0 is.
Yeah, we normally start with what? Because this is like y equals mx plus b, right? Surely you guys remember that. Your old friend y equals mx plus b? Yeah, so which one do you normally start with? What point do you put on the graph first?
The 2.
Yeah, in this case the 2. And where does that go?
On the y-axis.
Yeah, that's the y-intercept. And then, how would I get my next point? Yeah, down by 3 over by 1 or up by 3 over by 1. And this slope is positive or negative?
Positive.
Which way will it slant? This way or this way? This way? Okay. So it's going to go up 3, 1, 2, 3, and over 1. We could also go down 3 and over 1 this way. And there we go. That gives us our line. Oh, I want the one with... Oh, stop. Honestly. Don't laugh at me. It's okay, you can laugh. I would be laughing too. Oh, I've lost my breath. I give up. Dominic, what do manners make? That's right. So you keep that in mind, Kendra. You want to be a man, you're going to have to develop manners. What did I call you? What did I call you? Oh,
What?
wow. Listen, Caitlin. If you're gonna have bad manners, I will just make up random names for you. Some of them will start with K, others won't. Wow.
Well, you can spell
But you don't,
I know.
right? It's K-E-L-Y-M. How'd I do? Is that right?
Yeah, you're like the first person basically who has ever spelled it right.
I always, so I'm terrible with names. This is my great weakness. So whenever I get a new class, my only weakness, other than that, I'm essentially perfect in every way. But I always get the office to print off. They have like these health cards that have like your major allergies and things like that you get for field trips. The nice thing is it has like your last year's school photo in it. So I always try to get those printed off so I know kids' names when they come in on day one, if I know I have classes in advance. And I like study the names and study the spelling. And then if there's one that looks like it might be tough to pronounce, I try to ask other teachers so I don't butcher kids' names on day one. But I still usually spend like a month forgetting things and butchering names and things like stuff because I'm not good with faces and names. I guess that's two major failings. But other than that, I'm essentially perfect. Other than all the typos in the things. But other than the names and the faces and the typos, and all the times I get really confused up here. But other than the confusion and the typos and the faces and the names, and the vindictiveness where when people are rude to me, I just lower their mark for no good reason in the mark. But other than the vindictive mark lowering and the confusion and the typos and the faces and the names, I'm essentially perfect. So
Like Steve Martin's Christmas wish, where you just say one thing, like, no, never mind, I want to add another thing.
I've never seen that. Anyway, so what we said is that for this to happen, all of the x's become y's, and all of the y's become x's. So what am I going to have to do to this equation? F at x equals 3x squared means that the equation we are starting with, 3x plus 2. Education isn't something that was once a tree and then was beaten into pulp and then, actually it's a lot like education, really, isn't it? Bleached and whitewashed and then run through a press so that it comes out a specific shape and then cut with knives so it's a specific form factor and then sold in the store at a commoditized price. That's not what we're doing. Yeah, it kind of is. Okay. Anyway.
You solve for x and then you solve the x and y value.
Sorry?
You solve for x and then you solve the x and y value. Is that close?
You're on the right track. The second half of that was exactly right. We said that in the table of values, all of the x's became y's. Shh. You're almost 100% there. You're making it harder than it needs to be, but that's okay. Well, actually, not even that. You just put them in the wrong order. We said that in the table of values, everything that was an x became a y. And everything that was a y became an x. So in the equation, what are we going to do? Well, everything that was a y is going to become an x. And everything that was an x is going to become a y. Now this one's nice and easy because there's just one of each. But our new equation will be, it'd be what? X equals, keep going, 3y plus 2. There we go. Now, do we leave an equation solved for x? Is that how we normally express lines and things like that? No. So we want to algebraically rearrange this so that it's in terms of y equals. So let's do that. If I want this to be in the form y equals mx plus b, because this is still going to be a line, what do I have to do? Yeah, so let's get going. What do I want to move? Well, this 2 is cramping my style. So we'll say subtract 2 from both sides. What will that leave me with? Minus 2 equals 3y. And then, of course, I want to get rid of that 3. So what do I have to do? Divide by 3. And if I divide that by 3, got to divide everything by 3. Right? Both sides. And so what's that leave me with? Well, that's got to be 2/3, but the x was also divided by 3. So I'm going to write it in front like a slope normally is, 1/3 x. So it would be just as right to say x over 3. But usually with slopes, we wrote them in front as y over 1, right? Is everyone comfortable with that step? Can I talk you through it?
It'd be negative.
Oh, and it would be minus 2/3, yeah, equals y. So we had to divide everything by 3. So I've divided x by 3, I've divided 2 by 3, and I divided 3y by 3. X over 3, if I wrote that here, would be completely correct. X over 3 minus 2 over 3 equals y. It's just that usually, when we have the equation of a line, we say y equals mx plus b. We write it as a slope in front of the x, right? And so it is mathematically the same thing to say 1/3 x. 1/3 x is the same thing as x over 3. It's just two ways of writing the same fraction.
Why can't we just make it y equals sx plus y?
I don't know.
S is the slope.
Maybe they know that teaching grade 9 students y equals sx would just be exhausting, giggling from 14-year-old boys over and over and over again. That's probably it, actually. It's probably that simple. And then, of course, usually, what order would we write this in? Not mx plus b equals y, but y equals mx plus b. So how should I write this? 1/3 x minus 2/3. Just like that, but better.
Looks worse than yours.
Yeah, it's not as lovely, is it? Now, can we graph that? Yeah. So we would start at the y-intercept of negative 2 over 3. And what's our slope now? 1 and 3. So we would rise by 1, go over 3. We'd go down by 1 and over by 3. And now, yeah. And in theory, they should always meet at the reflection line, but obviously this is hastily sketched by hand. But if I did this in Desmos, you could do that.
Do it in Desmos for another 38 minutes.
Not going to happen. Nice try. All right, I want you to try the next one. Dear God, man. No, this one's tricky. This one is tricky. I will give you this one, because this is a parabola.
Oh.
Yeah, that's not too bad, but now I don't even know what to do anymore.
Wow, you're really upset about this.
Yeah.
Dan, it sounds like this. I feel really guilty. That's what I'd be saying if I cared. Now get to work. Get to work.
I'm gonna go on a strike.
No. That's it. Are you protesting with my textbook?
Yes, I am protesting with your map. This map.
That one right there.
Yes,
Yeah.
this one
Okay.
right there.
Get to
right
work.
Here.
Get to work. Well. Now what do you do? All of the y's have to become it. And all the x's have to become it.
So,
That's good.
this way.
That's great. That's exactly right.
Oh, I pretty much.
Yeah. The only thing I would say is I would remind you, it's 100% right. It does not need to be changed. But keep in mind that when you take the square root, the answer can be 2. Like say we took the square root of 4.
Yeah.
It could be good. So often we will write a positive or a negative in front of it just to remind ourselves that there's 2 answers. But you don't have to. What you have is 100% correct. It's a very good answer. Okay, whoa, really crazy. Get crazy. You're getting really nice. You can't break these up into Let me tell you what I
Why?
No, I didn't. Look at it.
Because you shouldn't.
I did it there with division, because that's how division works. That's not how square roots work. So let me show you what I mean. Look at this. Okay, 4 is 2 plus 2, right? That's a true equation?
Yeah.
Okay. What you just did is you said that the square root of 4 equals the square root of 2 plus the square root of 2. That's what you just did mathematically in yours. Is this a true equation? Is it? Square root of 4 is? 2. Square root of 2 is? Like 1 point something, right? 1 point, I don't know, 1.6, blah, 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 blah. So what you would have to say, this is not true. But this is
What
true.
is it?
There's no -2 in this.
So you can't do this, you can do that. It's actually easier,
Yeah.
because instead of having to draw 2 square roots, you only have to draw 1.
And then
Yeah.
technically, I have to.
Okay, but instead of drawing 3, you have to draw 2.
No.
Correct.
No. The why.
Yeah. That's what it is.
No, you're missing some. What
That's
did you
it.
just do?
Now, the only thing we have to keep in mind is when we take the square root, the answer may be,
No.
all true.
No,
But, well, it's true. Jesus in Sunday school.
Oh, so hard.
That's my knowledge, the square root of no number is Jesus. But,
There you go.
but the square root of 4 is 2. But it could also be
It's plus minus.
-2. It could also be -2. Anytime you take the square root, how many solutions are there? 2. So is this a function? No. Every y value is going to be double, right? Because you get the positive square root and the negative square root. So really, it equals plus or minus the square root. So it is, that is the correct equation for this reflection. But it's not a function. It's okay. It's a long line, but it's not a function.
Some of it is right. What are they all put together?
Can they look?
You don't know.
Yes, you are. That's exactly right. You don't have to do it. You don't get it.
I don't know. It's because I'm like
Yeah.
in here, but with animals, to know that I have that.
Yeah. That's the answer.
Oh my gosh.
What? Oh, somebody could just.
Slightly more Erickson.
You didn't finish it.
You did it all on your own.
Slightly
more. Rather now, come down here and switch it. Okay, may I go through this with you? All right. So the original function was f of x equals x squared plus 2. So if I wanted to write that back in kind of the way we wrote things in grade 10 with y's and x's, how would I write it? What? Oh, I don't want red. I'm a McCarthyite. Y equals x squared plus 2. Member of the John Birch Society here. Okay, so when we reflect this in y equals x, what do we have to do? Yep. That's right. Y's become x's, x become y's. So that y will become, I don't know what I said, but what's it? So what am I putting here? X equals y squared plus 2. Great. And now we're just going to solve for x. So now that we have this, we're going to solve for x. How do I do that? How do I do that? Yeah, there's that pesky 2 cramping my style again. So what's my next line going to be, Mr. Dominic? Oh, negative 2x. What am I doing with this? Am I dividing, multiplying, or subtracting, or adding? Subtracting. So am I going to write? I think you have it written right. Very good. X minus 2 equals
Y squared.
equals y squared. And I helped. All right, good. Now what can I do?
Square root.
I can square root. Correct. Now, keep in mind that if it's addition and subtraction, I have to square root the whole thing. I can't break it up into pieces. So what will my next line be? Yeah, y equals square root of x minus 2. Good. And now I'm going to kind of come over here because obviously that's not the form we like to see things. It's perfectly mathematically correct because I did. I don't know. Stop judging me. So I would say y equals the square root of x minus 2. Now, I'd like to keep in mind, and you don't have to, it's not mathematically wrong to write it like this, but I'm going to put this here just to remind us that every square root has two solutions, except for 0. So every square root has two solutions. Therefore, for every x value, how many y values will you get here? 2. Therefore, 2 y's for each x. Therefore, what can we note about this reflected equation? It's not a function. And that's okay. It's okay to not be a function. Some equations are functions, some aren't. Yeah. Y equals plus or minus square root of x minus 2. And I'm going to sing a Lady Gaga song to you about it. But I'm not actually, because I'm not a very good singer. But there we are. So, by the way, you've seen that equation before. Squared plus 2, particularly this parabola, except instead of being down 1, it's up 2. And when we flip a parabola in the line y equals x squared, we get this shape here. And of course, does this shape pass the vertical line test? It does not. So we can tell looking at it visually it's not a function. We can tell when we map it in a table of values that it's not a function. And we can tell algebraically to reflect it in the line y equals x that it's not a function. Isn't that kind of crazy? So I really quite like this stuff. I think they're fun questions. I think it's engaging. We have done all of the lessons in this unit. So I will walk you through timing. I'd originally hoped to get to test on Friday. I don't think we're gonna. I think we're gonna do our test on Monday, and I think that's okay. I think it's a good thing. The next couple days, we're just gonna spend consolidating. I'm gonna give you a little unit review tomorrow. We're just gonna spend a couple days practicing. I've got a couple practical activities. I do also have your next assignment.
I just did one.
Yeah. Assignment 2.2
That's
is here.
I bet you mine's on the bottom.
I tried to leave you guys lots of room. Actually, on the bottom today is the one that always spits out because I forgot to tell it not to print, called code, which just contains all of my, wait for it, code. Then retries 14 through 21, and then we come to yours. I tried to leave you lots of space to write on here. The first couple pages, you should be able to do there. All the mapping you should be able to do right on here. Now listen, this is good because it gives you some practice with mapping. I will mention that the last few days, like the stuff we've done in Desmos and some of the tricky ones I gave you in here, I will not give you complex transformations like those on the test. That's not what I'm looking for. I might do it from a table of values. I might do it from a graph where you're just doing it visually. But I'm not going to give you big, monstrously long algebraic expressions to work with on a test. I don't see the value in that or the virtue. But I will give you some ugly algebra on the assignment, which is to say there is contained in these pages a couple questions that have some challenging algebra. All right? The algebra can be tricky. They're not hard questions. In fact, they're very easy questions in terms of conceptually understanding what to do. It's just they do have some tricky algebra. You might get a little scared off by it. I encourage you not to do it. I'm going to try my absolute damnedest to have Your assignment 2.1 is back to you tomorrow. I feel guilty I didn't have them back to you today, but I just could not get to it yesterday because I was working on a very exciting new set of code that lets me put fractional A and B values in here. Yeah, right. I was excited too.
That's
So
disgusting.
so that took up roughly 6 hours of my life I could never have back last night, which precluded my marketing assignments. So do you want to see? Let me just show you, just for my own sake, the coding of just one of these questions, like just this guy here. Oh. I tell you, being brought to the same school as Calford and being like, having him to show me how to do this stuff has been great because it's making my questions way harder, which is nice. So you're welcome.
Yeah, we gotta go beat up Calvin.
Don't beat up Calford.
Well, now that I know that you are teaching him how to make coding questions, now we can.
And there it is. Yeah, so that's the generating code for one of those questions. And that only works after I've already done, there's a whole bunch of VBA script. Anyway, I went through 2 of these worksheets myself. All the questions look like they're good. It didn't look like any are behaving screwbally. Having said that, the hardest thing in the world, would some try and pull these up? Thank you very much. One of the hardest things in the world to try to do is to get a computer to write a sentence that makes grammatical sense. And in this case, the reflections, like maybe it's reflected in the x-axis, y-axis. Because it randomly generated, I didn't know how many there would be transformations. So to try to get it to use commas and the word and properly can be really, really, really difficult. So I think I did well. But if you read some of these sentences and there's just like a strange comma with no space, or 2 words smushed together with no comma at all, or all of the word ands and no commas, I did my best and I apologize for the grammatical atrocities that may be contained herein. But it should be good. The first couple pages of this should come very quick to you. The last couple pages will probably take you a bit more time. That's okay. Tentatively do Friday. If we feel like we need more time, talk to me. I don't know how long this will take. Stop. You haven't even looked at it yet. You haven't even been handed it yet.
There's a lot of pointless commas here. Now that you mentioned it, I'm saying it's like.
No, they're not pointless commas. You need to have a comma between each thing in the list, I think. If you just mean like the sentence at the back, that's just how I write.
These are not capitalized.
What's not capitalized? They are all capital. They are all capitalized. Because, no, it is completely appropriate. Good Lord, people, go to English class. Each of them comes after a colon, and so each of them is a continuation of the sentence that was in the header. So the sentence is, listen, the sentence is, write an equation for each of the following transformations when f at x is reflected in the x-axis. They're a continuation of a sentence that started elsewhere, so they shouldn't be capitalized.
He has it right.
They should not be capitalized.
No,
I think I am often willing to admit when I'm wrong. I am clearly correct here.
No, you're not.
No, he's
You're
actually
welcome.
right this time. I will actually admit that you are right this time.
Yeah, listen, even
Right.
even a broken clock is right twice a day, and as it happens, I'm right. What? Yeah, see? Unless it's like a digital one like this, that could potentially be never right. Because it could just be stuck on a number that doesn't even exist, like when that has like crazy things to do. But like if you're talking like an old analog clock twice a day, I think it's going to be right. That's what I am. I'm the big broken clock standing up in front of the room, sharing my wisdom with you. All right.
That's only right twice a day.